Tech Transforms explores how technology is reshaping our world, specifically at the intersection of government, innovation, and human needs. In each episode, I talk with some of the most influential voices in technology, uncovering how they're leveraging innovation to solve complex challenges and improve the way we live. This episode is sponsored by Owl Cyber Defense, enabling high-assurance organizations to securely share mission-critical communications, audio, video, teleconferencing, and more, while ensuring compliance, reliability, and protection from ever-evolving threats. And ATARC, that provides a human forum between government, industry, and academic leaders to resolve emerging technology challenges. I'm your host, Carolyn Ford, and today we're diving into AI and cybersecurity in the federal government. Joining me is Martin Stanley, Senior Advisor at NIST. Martin has been on the front lines of digital transformation, helping shape how our government secures its systems and responsibly integrates advanced technologies. And he's helping guide the federal approach to some of the most powerful and potentially risky tools of our time. Welcome to the show, Martin.
Thank you so much. Very happy to be here.
Well, I'm excited to talk about this. This is one of my favorite topics, AI in general, and then the security side of it, the cybersecurity side of it. So you're at the forefront of federal cybersecurity strategies. You've helped co-author many of the NIST guidelines that shape the cybersecurity guidelines. So how is AI changing that risk landscape, and how are agencies adapting?
Sure, great question, and thanks again for having me here. The NIST has a long history of leading on cybersecurity, and we've been also leading on AI risk management. Our AI risk management framework is the program that I lead, and we work very closely with the cybersecurity team here, in particular because security of AI systems is one of the main aspects of the AIRMF. There's 7 trustworthy characteristics. One of them is secure and resilient. So ensuring and assuring the security of an AI system is fundamental to being able to trust that system. And adapting the cybersecurity guidance that NIST has to the differences that are present when you introduce AI and machine learning infrastructures into your organization is something that we're focused on as one of our number one priorities here. We recently conducted a workshop in April to hear from the community. We had about 5,000 people participate, most of them online, but a bunch of them showed up at the National Cybersecurity Center of Excellence in Gaithersburg. We had a couple panels, and then we had some breakout sessions in the afternoon where we got feedback from the community on what would be helpful for various representatives from various communities to make sure that we were able to expand our guidance to meet what the gaps are for artificial intelligence systems being secured. We do know that one of the primary vectors for vulnerability for AI systems today is the traditional cybersecurity vectors. So it's really important that we get this guidance out and that we update it. AI systems differ, obviously, in that they reason and they act upon virtual and physical worlds. So it's a little bit different than what we're used to with confidentiality, integrity, and availability. Risks and impacts. The AI systems typically have a much broader capacity to impact. So we need to understand these differences. How do we secure models from being stolen? How do we secure the training data? How do we ensure that the inputs and the outputs are secured? We have traditional approaches for that. They are IT systems, and all of those things apply. But there are some additional capabilities that are necessary. So that was the project that we began back in April, and the outputs that we are going to produce, sort of in order that you should expect to see them, are we will produce an 853 control overlay, which is a adaptation and augmentation of the current 853 control set for artificial intelligence systems.
When you say 853, do you mean literally 853 controls.
No, that's fine. No, I mean this special publication 853. I will have to tell Vicky that you said that because it's funny. Sh-
I'm
so
like, that's too much, Martin. It's too much.
so what an overlay does actually is provides a simplified view of what are the differences. And so we did a control overlay for high value assets. And
Mhm.
if you look at that document, that's a CISA document.
And
So
when you say high value assets, do you mean like top secret networks?
no. So that's back sort of in my old job at the Cybersecurity and Infrastructure Security Agency. We created a control overlay for the most critical federal systems. This was after the OPM breach. So
Mm,
all agencies had to identify
okay.
their what were called high value assets.
Hmm.
So similar to that, we're going to be creating a overlay that's focused on those unique AI characteristics and making sure that when we apply these controls, they meet the objectives that we have. So
Okay.
that's the first thing. The second thing that we'll be producing is a cybersecurity framework. So the CSF, a profile of the CSF for artificial intelligence, and that profile is going to cover protecting AI systems from cyber threats. It's
Hmm.
going to cover use of AI in cybersecurity, and it's going to also cover adversarial use of AI, so that people have a better understanding of the ways in which they can defend against those kinds of threats. So that's going to be a more expansive effort, and then we'll be doing some other things here at NIST as well to help people with updates to our documents to ensure that we account for these differences of AI systems just in the cybersecurity domain. And then, of course, we're doing some other things as well.
So you said, like, when you were identifying the gaps to secure AI, like the biggest vector or one of the main vectors is just traditional cybersecurity. So give me an example. Tell me a story.
Sure. So we recently, and I think we're going to talk about this a little bit. We recently released an update to this secure software development framework for generative AI and foundation models. That's just in the software development lifecycle, the actual development part of the life cycle. But within that, people are using new tools and capabilities. They're often implementing them with any privileges or system level privileges, which is
Mm.
something that we typically manage through like a zero trust kind of approach,
So it could be like a
because
back door that
it
it could be used
or
that
it could be a method to move laterally, if
way. Yeah.
people compromise.
Hmm.
Um, we are also very familiar with injection attacks, but these injection attacks with prompt injections, for example, can be very different in AI if we haven't fully secured the back end, and then it can have other kinds of consequences because of the privileges that the system has, as a result. So these are the kinds of things that we're seeing happen every day.
We have had this happen
Oh yeah, yeah. These
on
these
our critical systems.
well, I don't know about critical systems, but we there's tons of instances of these, and there's a whole industry of companies now that are working on developing solutions to scan your models, to secure inputs and outputs and that kind of thing, just for cybersecurity.
And I think you said when this group got together to identify some of the gaps, you talked about how to protect it from being stolen, how to protect the training data. So tell me more about that. What do you mean?
Sure. So, one of the things that one of the vectors for compromising an AI system would be to get access to the model. If you have access to the model and somehow you're able to then manipulate the model or learn how to manipulate the model, outside of its protected environment, that may inform you of ways that you can actually affect the production deployment. So you really don't want to let people have access to your
Mhm.
model. So that's one vector that you want to close down, and there's methods and techniques, to mitigate that particular vector. Training data. Oftentimes, we're training these systems on data that's sensitive or has other kinds of considerations, whether it's regulatory, compliance, or other kinds of concerns. And that training data has been demonstrated to be, vulnerable to all kinds of different vectors as well. Certain queries to the model that actually get the model to give you the training data,
Mhm.
or aspects of the training data, or you can infer things about the training data that might then, create privacy or other kinds of concerns. Um, or the data itself that's training the system is being modified or changed,
Mhm.
and then the model itself will not perform as well, or will not perform, as you're intending, because the data has been changed,
Mm.
and other kinds of ways of, fooling the model, through confusing the inputs, and that kind of thing. So there's many just traditional vectors that have now new consequences, and require some additional measures to protect.
Are you using AI um, in cyber defense, or how are you using AI in cyber defense? Well, and also, are you using AI to figure out how to secure AI? Two different questions.
Well, I think so. I think yes to all of that. And one of the things that we're trying to understand better is by introducing AI into cyber defense, we have got to be able to respond to cyber attacks at machine speed.
Mhm.
And so that means we're going to have to trust these systems to perform autonomously, whether they're AI or something else. We're going to have to trust them to do things autonomously. And how do we do that? Well, that's something we're still figuring out. We can use AI for that. Many of the things, when you think of, like, when you hear the term guardrails, with respect to AI systems, oftentimes those are other AI systems that are, you know, that are focused on particular aspects of either not letting certain kind of queries in, or not letting certain kinds of outputs out, or the like.
So are those guardrails, you helped lead the work on the NIST generative AI profile.
Yes.
Like, the guardrails, is that part of the generative AI profile? And if it is, tell me more about that.
Sure. So, obviously, 2023 was a pretty big year. For us, we released the generative AI. We released the AI risk management framework, and then a couple months later, ChatGPT came out, and everybody, was immediately. I think the most important thing to say, because we're talking about risks and concerns, is there's a tremendous opportunity here, and everybody immediately saw why we should be looking at adopting these technologies. So we don't have the opportunity to say, well, we're just not going to use it because, people are going to be using it. We have to use it.
Mhm.
Um, we had, at that point, it was about the time I got to NIST, we began a public working group on generative AI around four areas. We wanted to come up with some additional guidance that we could provide. We ultimately wrote something called a profile of the AI risk management framework. This is the generative AI profile, and NIST AI 600-1 is the actual document number. And so profiles of frameworks at NIST are generally very flexible. There's a number of profiles that we have linked on our AI resource center that people have created. And we're working with people, routinely to create profiles. And I mentioned, we were talking about doing one similarly for the cybersecurity framework.
Mhm.
Um, the generative AI profiles is specifically focused on the unique or exacerbated risks. So risks that are either unique or exacerbated by the use of generative AI. Um, and we identified 12 risks. They're enumerated. And then we took those risks and we went through the AI risk management framework, which the profile is based on, and we identified suggested actions. And so, to your question about, does it specify guardrails? In many ways, in many places, within the suggested actions, we talk about the application of guardrails, being able to measure their performance to assure yourself that they're working, and then how to make risk informed decisions about the operation of your generative AI system based on the data that you get from the performance of these guardrails. So that is part of the suggested actions, is to apply guardrails to generative AI systems.
I know, I mean, every company is asking, do we allow the use of generative AI? I've been with companies and know of many companies that don't even allow it,
Mhm.
just because of the risk of lost IP. And this profile, first of all, 12 is a manageable number. I like that it's not 600, but it's 12 guidelines. Um,
12 risks. 12, yeah,
risks,
12
but then
risks.
you map them to mitigation. So this sounds like a really good tool for leaders within organizations and agencies to start here if they're asking themselves, do I allow generative AI? Do I not allow generative AI? This is a really good place to start.
So going back to the AI risk management framework, which is my program here at NIST, the AI risk management framework, generative the 600-1 is a profile of it, but the framework itself has a couple of core concepts. Obviously, there's 4 functions. The govern function is where you create what we call a risk-aware culture, which is, I think, to your point of understanding what you're getting into,
Mhm.
and making sure the right people in the organization understand what you're getting into. And then
Mhm.
the 3 other functions, map, measure, manage. So map is where you understand what is your deployment context, how are you actually using it, what are the risks associated with that. Measure, how do you measure whether or not you're seeing risks, impacts, and most importantly, benefits? Are you seeing the payoff that you were expecting? And then manage is how you take all that information and make risk-informed decisions about where and how and how to and whether you continue using AI. Um, Generative AI is so pervasive. I don't know how you can, determine.
Listen,
um,
I know people that have told me that work for companies. I have a friend that was told they can't use it at their company. So
Yeah.
you just use your personal laptop. I mean, you get around it because we can't keep up with the competition.
Well, and this is shadow IT. I mean, this is something that happens in every organization that you get concerned about when you have these kinds of restrictions. What's necessary is same thing that we've done with any other technology, is training and education and
Mhm.
and risk management, applying protections like we're talking about. Um, so for example, one of the reasons that organizations say you can't use like in a publicly available generative AI model is, as I mentioned before, when you're training a model, one of the risks is that the training data can be stolen. Well, if you're using proprietary information, if you're using information that needs to be protected
Right.
into a publicly available generative AI model, all brands apply here. Um, Somebody could theoretically query and get that information out, somewhere else.
Mhm.
Um, it's being stored, it's being used to train the model. So how do you protect against that? Well, at NIST here, we've protected against that. Um, we have an internal model that we use that we're allowed to process controlled unclassified information on it. A
Mhm.
number of other federal agencies have that. Tons of organizations have their internal models that they use because they know that only the the people that are using that model all are authorized to have access to that information, and then they can protect it.
So
That's a mitigation.
when you say an internal model, so it can stay, I guess it depends on why you're using it.
Mm.
So my world of marketing, like I need it to know what the latest greatest is. So if I had an internal model, here's how my brain thinks of it.
Hmm.
Is that I've got this air gapped internal model that is not connected to the outside at all, unless, nope, let's stick with the not connected to the outside. But then maybe on a daily basis, somehow, this sounds impossible. I suck in everything, all the updates I need from the outside and update my internal model. Is that the way that works?
Well, the model providers will provide you with, if you subscribe to it, or if you're using, open source models, you could just
Mhm.
download them when there's a new version. And then
Okay.
so it's trained, you've brought it into your environment, and that's it. It's not connecting. And then when you update it, then you know, start with a new model.
Yeah. And are you maybe your the way you use it at NIST, you really only need it updated with your data, so you don't need anything from the outside, so you keep it
Well,
off
so,
that
so this
dirty
is a gen-
network?
this is a general purpose trained, generative AI model. So we
Yeah,
use Llama, here in NIST, but others might use Claude or
sure.
ChatGPT or something like that. And that model gets updated, and you know Llama is open source, so you can just download it. If you have a problem with it, you can uninstall it and reinstall it. So it's already trained on this broad corpus of information. So it
Mhm.
can speak to, any kind of question that you might ask. What's not happening is it's not being trained on the inputs of, the entire world. It's only being trained on the inputs of your users. Which is fine. It keeps it contained. And obviously, we're getting into a lot of, technical detail here that most people won't, necessarily may have familiarity with. But you can do things like you can train the model using techniques like retrieval augmented generation. This is RAG is the common term, where you're using a certain corpus of your own, maybe internal documents, to say, um, I want my I want my outputs to use these documents as the reference for the development of, some particular output. Um, there's all kinds of techniques that people can use, but you're getting a fully functional, general purpose, model when you download, Llama or anything like that.
Okay. So I threw a whole bunch of questions at you at once, and I wanna circle back and see if
Sure.
we answered the
I like it like that.
how you're using AI in cyber defense. You said, we have to use it to keep up with the competition. Somehow we have to trust it at some point, figure out how to trust it, keep the human out of the loop because we're too slow. Our meat computers are too slow. So are you using it for cyber defense right now, or you're trying to figure out how to use it?
Well, we've been using AI for cyber defense. Spam filters have
Mm.
long, been, there's multiple, ways in which people have been using AI. You maybe more manually over the year to do like log analysis when there's, an incident, you're doing incident response, that kind of thing. But what we're talking about, I think, is some more systemic, applications to enable what I refer to as, machine speed,
Mhm.
response. And that's one of the things that we're trying to get a good understanding of through our, public engagements is what's the current state of the art, like what is currently possible out there? How are people looking at this? What's mature in the marketplace? Where
Mhm.
are the gaps? What are the as I mentioned, we have this map, measure, manage. So like in the map function, what are the deployment contexts that people are considering? What are the risks associated with that? How do we measure to see if we're seeing those risks? What are our thresholds? And then lastly, how do we decide, whether to use it or not? So that's exactly the project that we're involved in now.
So risk aware, map, measure, manage was number two. And then what was number three?
The AI risk management framework has four
Mhm.
functions.
Right.
Govern, which is, the sort of like central function,
Okay.
have a risk aware culture, have
Yep.
people that are thinking about this. And then the three other functions are map,
Map,
measure,
measure,
manage.
manage.
Yeah.
Awesome. Okay. Okay. So let's talk about your other NIST 800-218A focused on dual use foundation models. I don't know what that is. So explain to me what a dual use foundation model is and how it matters
Yeah.
with what we're doing with AI and cybersecurity.
Yeah, so 218A, the secure software development framework for generative AI and dual use foundation models is focused on the development part of the model life cycle in the software development life cycle.
Mm,
Dual use models are typically, models that may be created for one purpose that could potentially be repurposed for something else.
okay.
So, when we think of dual use, we usually think of things that are, we intended it to be used for one thing, but then it could go be used for something else. And oftentimes there's like a malicious, kind of component to that.
Sure. Okay. Does NIST do like general training to agencies, like 101 based on these guidelines that you write?
Yeah. So any agency, and we've spoken, and I mean, I've spoken to. This has been a large part of what I've been doing for the last 2 years. We regularly go talk to IT organizations. We talk. Haven't talked to so many lawyers in my life than in the last 2 years. A lot of the legal and compliance groups are like really interested in the
Mhm.
questions you've been asking, and what's possible and how do they go about preparing their organization for the use of this technology. We do all that kind of stuff. Obviously, we'd like to do more. I imagine that we will mature to the point that we actually do have some more formalized training. But we're really right now in a information gathering mode to understand as people are adopting the ARMF. We have a lot of early adopters. How is it going? What's the additional guidance that we need to produce? I think we have an idea of a few things that we need to deliver that would be, very helpful. We've gotten tons of feedback from the community. We've got overwhelmingly positive comments. I think there was a recent RFI from the administration where there were thousands and thousands of submissions that talked about how great the ARMF was, which was, great for us. That was good to hear. But now we really have to elevate our guidance so that we can get more specifically into what are the particular tools and techniques that you can use to accomplish the objectives that are laid out. You mentioned, on the cyber side, the 853, NIST Special Publication 853 control catalog. We actually don't have anything like that for AI at this point. For AI, we have the this understanding of a general risk management approach. We understand the risks, what comprises trustworthiness. There's 7 trustworthy characteristics. We understand like the risk domain is people and planet. These are systems that reason about and then go and interact with the real world,
Mhm.
virtual worlds as well, and all other kind of thing. But they interact with the real world. So that means anything that's in the real world now potentially has to be considered for potential benefits and impacts.
Mm.
And so very much so, this guidance gives people gives users and deployers and people throughout the AI lifecycle the necessary resources to be able to start to understand and contemplate what are these concerns, what are these opportunities that they have, and then we have suggested actions. Hey, for this particular concern, you might look for, this kind of guardrail, for example. But what we don't have is like a catalog of here's the 10 guardrails you would choose from, and here's why you would do that.
I
The
mean, is that a
it
goal?
just
Because it seems
it's
like
not
that's
mature enough. Yeah.
okay. Is it even possible? I mean, because like you said, you have to anything in the real world, like it's infinite. Like, how do you write controls for that?
Well, so this is one of the things that we're we're contending with now is how do we how and I actually think I think the answer to the question is actually there are controls that can be applied.
Okay.
And they're um, they're ones that in particular areas really depend on the maturity of the actual use case. and the amount of resources that are applied, in those domains. But yes, I do think this is feasible. It's probably going to be a large part of the work that we're going to be doing over the next couple of years is to really understand for these actions, what are the methods and what are the tools that are available to actually achieve those outcomes.
Yeah. I mean, just like we said, there's so much noise around AI trends. What's one of the AI trends that you think is just really overhyped and one that you think maybe is underhyped that should have a little more attention?
Right. So I think the nature, and I keep going back to the definition of AI systems because this idea of reasoning about and understanding what's going on under the hood and what you can understand versus what you can't. These are non-deterministic systems, which means that their behavior changes over time. Their capabilities and their capacity can change over time, which is
Mhm.
not something that we anticipate or account for typically. And the kinds of risks that we're concerned with, confidentiality, integrity, availability of IT systems is managed through cybersecurity.
Mhm.
AI risks, which are, to this process that we're talking about to, through trustworthiness, um, those are different. They're related to the ways that AI systems behave and what are the consequences? So I'll give you a really quick example. So when we're looking at AI systems, we're looking at things like model behaviors of overfitting or underfitting. So overfitting, for those that are not aware, is you tend to bring in more responses than is sufficient. So for example, or that are you're bringing in more responses that are appropriate. So if I'm on my Netflix, account and it's recommending all the things accurately that I should be recommended based on whatever the criteria is that it's doing that, and then a bunch of other things, for example,
Mhm.
that's not so harmful. Overfitting. In fact, it's probably good for Netflix in that case because I'm probably more likely to stay within their application, within their environment, rather than come back with nothing, which would be underfitting, right?
Right.
If I'm driving a car and the computer visualization system is overfitting on its detection of stop signs, which means it's interpreting more signs as stop signs or more objects as stop signs,
It's my Ring doorbell, Martin.
right?
I have a flag on my front porch. It tells me there's somebody at my door continually.
Right. So well, it's telling you there's motion, but yes, it's yeah.
The message
But
is there's somebody at your front door.
well, so that's overfitting, right? And you probably would prefer overfitting than underfitting because underfitting means there's people showing up that you're not aware of.
Well,
But within that, that's that measure function that I was talking about with figuring out. So organizations have to pick deployments where they're actually going to use AI, and they have to think through and understand, well, what is my error bar, associated with
right.
this
I mean,
performance of this
I
task.
ignore my Ring doorbell at this point. It's not useful information anymore because it's so overfitted.
Mhm. Well, but is it using AI or is it just using computer visualization? Maybe an AI algorithm on top of that
There we go.
that was trained where you went through and you said, don't show me any of these and show me those.
Yeah.
Then it would
Don't
actually
show me the
produce.
flag.
Right. It would. So these are the kinds of things that people are using AI for. So overfitting, underfitting, and then of course model drift
Mm.
is the idea that over time, whatever performance you had changes based on whether the system is experiencing different kinds of data inputs or other factors, which you have to be able to detect that so you can determine whether or not it's still functioning. So
Like
deep
my
breath there, and I'll give you one other example, which I think is also something that's really important. So, one of the trustworthy characteristics is explainability. And so we want to be able to, for applications, for context of use where explainability is necessary, where we can demonstrate how a determination was made, we're required to, either legally, morally, however, if there's some other business purpose, choosing a algorithm that is that has explainability, as part of its characteristics, or it's more explainable than other algorithms, because many are not. Um, that's like a really important design decision. It's things that we talk about within the framework of, this is things you need to be thinking about at design time. If you have an application, if you're going to be using this for something that requires explainability, pick an explainable model.
Mm-hmm.
And then as you're doing your deployment, come up with what's called post hoc explainability, which is, come up with a way of determining and explaining the outputs of the system, because you're going to get asked questions. There may be recourse that people have. They may be asking for a human to intervene. They might be asking for decisions to be explained. You might have regulator. You might have other kinds of considerations around that. These are the kinds of discussions. If these are the kinds of discussions that are happening in your organization when you're considering using AI for a particular deployment, then you probably have a risk-aware culture, like we talk about in Govern, and you're probably doing a lot of the right things. If these conversations aren't going on, then there's probably some maturity that needs to happen.
Yeah. I think it's really important. I'm looking at the different documents that you've helped co-author. When I think about AI, I think about my world and how I use it, which is generative AI. That's just one
Type of AI.
right?
Mm-hmm.
And so I think even as you're talking, I have to remind myself, oh, he's not just talking about generative AI, or like a lot of times when you're talking, you're not talking about generative AI at all.
Right.
And so you have to think about what kind of AI tool you're what kind of AI tool you need, if you even need an AI tool. And then it's nice that you've written different guidelines. You've got one for generative AI. So look at those guidelines for that AI tool. One thing doesn't apply to all.
Correct. And I think there's some generalizations that you can make, but as we were talking about, from an explainability perspective, like, you wouldn't use generative. Generative AI defies explainability. It's very difficult to say. If you ask for explainability, you get a vector back. Like, this is the next choice, the prediction was a vector, and that was it. If you're using a decision tree, sort of kind of a classic sort of machine learning approach, those are far more explainable, right? Because it's even if as long as it's not a very complex decision tree, but
Right.
typically decision trees are considered to be explainable.
Right. So for federal leaders that are ready to start using AI securely, what's one practical step that they can take away right now this month and start building some risk-aware strategies?
So this is a great question. And I'll just go back to what we said, at the beginning, which is, first and foremost, these are IT systems that should be managed within your, current IT regime, and in particular, ensuring that you have the right kinds of cybersecurity applied to the infrastructure, zero trust principles, and that you're looking at the various tools and capabilities that are commercially available already to scan models and to build layers of defense around models when you're moving them into production. I think that's probably, like, first and foremost. Thinking about policies that make sense. For example, as we talked about, if someone doesn't have access to the training data on a general basis, like if there's someone in your organization doesn't normally have access to a particular data set, they probably shouldn't have access to the model
Mm.
to
Mhm.
query it. Right, these are the kind of like basic sorts of things which I think people can do today, and really decide what's your success metric. Like, so there's this M2521, the OMB memo 2521, which is for high impact uses, and there's a big section in there which is new, which talks about agencies having to demonstrate the success. So how are you measuring the success of these deployments? That's something that's also important too.
Mm. So, as we're looking at securing the IT systems, which one of your documents should we go read? Like, is there a list of best practices? Which one do we start with?
Sure. So, I mean, of course, you want to use all of if you're in the federal government, you want to use all your favorite document, 850 special publication 850, which is all the cybersecurity controls.
Right.
Those are in baselines, which I think people already have and apply. You want to make sure that you're applying those. If you're actually going to be building like a machine learning pipeline, if you're actually going to be building models and training them yourself and all that, you want to look at the SSDF. That's the special publication 218A, 800 218A, which will give you suggestions about how to further protect your machine learning infrastructure. And you can look at our AI risk management framework, specifically focused on the secure and resilient. There's 7 trustworthy characteristics, but secure and resilient enumerates the specifics around these model vulnerabilities that we spent a lot of time talking about earlier.
And these are all at NIST.gov?
All at NIST.gov.
Okay. All right. It's time for our tech talk questions. These are
Or
fun rapid fire questions. Just go with your gut. So, first question is, we're celebrating our 100th Tech Transforms episode, and I'm asking all my guests, what's the weirdest piece of tech you've seen in the defense or federal space?
hmm, a YubiKey.
A what?
Exactly.
Is it
It's a little token for remote access that you connect into your one of your USB ports. Uh,
okay?
yeah, it's
So, like an RSA token, but you
well, it's a physical it's a physical I guess
that you actually plug in.
certificate. You
Okay.
plug it in. Most people are
Sleeves.
using we're not using them anymore, thank goodness.
All right, all right. Um, if AI were a sci-fi character, who would it be and why?
Well, I mean, I think we've actually seen many of them. I think we'd like them to be like Jarvis, in Iron Man. I think
Yeah,
that's what we would
I
like.
really want a Jarvis, really, really bad.
But I think actually, if we really want to talk about what, at least when we're talking about AI today,
Mhm.
uh, I don't think AI today is as competent as like a 3-year-old.
Right.
And getting keeping itself out of trouble and surviving in an environment, because the AI systems that we have today require tons of training data in order to function in a very, very narrow range. And
Yeah.
one of the really cool things about humans is we generally tend to make it through on little or no examples in some of the situations that we find ourselves in throughout our lives. And
Mhm.
you can think about all those kinds of things where you're like, what do I do here? And somehow you seem to make it through and get home.
Right. Yeah, I mean, the human computer is pretty cool, and
Mhm.
we haven't figured out how to duplicate any part of nature yet, like the quantumness of nature. So,
And I think that's a big challenge with AI systems. People use this anthropomorphize, term, which is I don't, not it's not my favorite term, but AI reasons and acts in the real world, but it's not a person,
right.
and it's not a pet, and it's not living. So, to attribute those kinds of traits to it is to create blind spots.
Mhm. All right, last question. you've got a time machine and a USB drive, or what did you call it? A UV stick?
UV key.
UV key. What AI or cyber guidance would you take back to 2010? So this is pre IBM Watson days.
Well, I mean, I think people probably should be encrypting their data more because a lot of data has been stolen, and probably encrypting it so that it would be not vulnerable to decryption down the road.
Okay.
For sure.
Oh, so you just want to go back and like hit people up the side of the head and say, "Stop being stupid"?
Well, it would be nice to take some tips back too.
Oh yeah. Yeah, that would be nice. All right. Um, what's one step leaders can take this week? So we talked about, this month, what they can start with, but what can they do today to strengthen their AI and cyber risk posture?
So I mean, I think the number one thing, and we talked about it, is just to ask the question: are we making sure to apply cybersecurity the way that we do in the rest of our organization to our AI and machine learning infrastructures? Because if we're doing that, we're mitigating so much of not all the risks, but we're mitigating so many of the current vulnerabilities that we have with these systems. We still have all these concerns about the actions that these systems take in the real world and those kinds of impacts, which aren't mitigated by cybersecurity. But we do know that these systems are incredibly vulnerable when they're not protected properly.
Yeah. It just I know you've said it multiple times since we've been talking. It seems like it's a no-brainer that you would apply these cybersecurity controls to your AI um, models, your AI instances, but it's
It's not a no-brainer because people are in a rush. They're in a rush to
fair
see
enough.
benefits, and oftentimes when we rush into things, we don't always take all the precautions that we should.
Yeah, fair enough. All right, finally, where can our listeners connect with you or follow your work?
So we have what we call the AI Resource Center at NIST. There's we have a full website, and people can always reach me at my NIST email address, martin.stanley@nist.gov.
All right, we're going to add that to the show notes. Thank you so much for your time today, Martin.
Thank you. This is fantastic. Appreciate it.
Yeah, really fun. And thank you, listeners, for tuning in. Please share this episode, smash that like button. And until then, stay curious, stay agile, and keep imagining the future. Disinformation, AI drift, split second choices. At the Owl Evolution Summit, October 24th, 2025, you'll face them all. Then see how mission wins. Reserve your spot now at owlcyberdefense.com/summit. Thanks for joining us on Tech Transforms. If you enjoyed this episode, please smash that like button and talk about it with a friend. I'm Carolyn Ford, and this is Tech Transforms, brought to you by Owl Cyber Defense and ATARC.